Hello students, this is me Ilakya. Welcome back to our next class. So today we are going to look at a very simple problem which is familiar to everyone, but its solution wouldn't be accepted by most of them. But before looking at the problem, let us recall about fractions and decimals. So you have already learned about fractions and decimals and also how to convert the given decimals to fractions. Now let's see some examples of converting the given decimals to fractions. So your first example is convert 0.75 to a fraction. Basically it involves 3 steps to solve this question. Your first step is write down 0.75 divided by 1. And your second step is multiply both top and bottom by 100. Why it is 100? Because there are 2 digits after the decimal point, so that is 10 into 10 which is equal to 100, so that you get 75 by 100. And your third step is simplify the fractions. So as you can see, 75 by 100 has a common factor, so if you simplify it you would get 3 by 4. So your answer is 3 by 4. Let's look at another problem. So your second example is convert 0.333 to a fraction. So you're going to follow the same steps which we followed in the previous sum. So your first step is write down 0.333 divided by 1. Your second step is multiply both top and bottom by 1000. So why it is 1000 here? Yes, 3 digits after the decimal point, so that is 10 into 10 into 10 which is equal to 1000, so that you get 333 divided by 1000. So what is your third step? Third step is simplify the fraction. But can you simplify it further? It can't get any simpler. So your answer would be 333 divided by 1000. So if you have a problem like 0.333 dot dot dot, in other words 3 is repeating forever, which is called 3 recurring. How would you convert such kind of decimal into a fraction? Well, we'll follow the same steps. So your first step is divided by 1. So 0.33 repeating forever divided by 1. So your second step is multiply. But can you count the number of digits after the decimal point? No, it's not possible, right? So we'll look at the problem in different way. Let's multiply this with 3 so that you get 0.999 repeating forever divided by 3. Can you solve this further? In order to solve this further, you need to know what is 0.99 repeating forever, right? Well, we'll see what is 0.99 recurring. We have a very simple solution to convert such type of recurring decimals to fractions. So here's what you need to know. So if you have a single digit repeating value, write the repeating digit over a denominator of 9 like this. So if you have 0.111 recurring, your 1 is a single digit which is recurring, and you just have to write the repeating digit over a denominator of 9. So the value of 0.1 recurring is equal to 1 by 9. And if you have a 2-digit repeating value, write the repeating digits over a denominator of 99. So if you have 0.121212, in this case 12 is a 2-digit number which is repeating, so you just have to write the repeating digits, which is 12, over a denominator of 99. So your value of 0.1212 recurring is equal to 12 by 99. And if you have a 3-digit repeating value, write the repeating digits over a denominator of 999. So if you have 0.123, so in this case 123 is a 3-digit number which is repeating. So you just have to write the repeating digits, which is 123, over a denominator of 999. So the value of 0.123123 recurring is equal to 123 divided by 999. So using the same solution, let us go with 0.99 recurring. So you just have to write the repeating digit, which is 9, over a denominator of 9. So your value of 0.999 recurring will be equal to 9 by 9, which is nothing but it is equal to 1. So 1 is equal to 0.999 recurring. Try to convert such type of recurring decimals to fractions using this solution. That's it for today. Thank you, students.